Hello students, welcome back to Future Foundation. In last class, we have discussed normal form and did some examples. Students, now in this class, we will talk about parametric form of a straight line and will discuss some questions based on it. So let's start the class. Seventh form is parametric form. So in this, first we will write, suppose a line is passing through a given point x1, y1 and is inclined an angle say alpha with positive x-axis, then its equation is given by x minus x1 on cos alpha is equal to y minus y1 upon sin alpha is equal to r. And in this, r is parameter. What I have said in these lines, I will tell you through diagram. Now as a line is passing through a point x1, y1, say point is here, P, x1, y1, and it is inclined an angle alpha, this is alpha. So equation is given by this, right? Now we want its proof. How can we get this form? So let's say any general point Q, x comma y at a distance r from P. Now complete a triangle PQR where R is at right angle. Now from figure, if this angle is alpha, then angle QPR is also alpha. Now from triangle PQR, sin alpha is QR upon PQ. QR is y minus y1 and PQ is R. So I can say R is equal to y minus y1 upon sin alpha. Similarly, cos alpha is PR upon PQ. PR is x minus x1 upon, again PQ is R. So I can write from here R is equal to x minus x1 upon cos alpha. So I can write x minus x1 upon cos alpha is equal to y minus y1 upon sin alpha is equal to R. And this is the required form. The question arises, why do we need this form? We have already discussed 6 forms. Then why we need this particular form? So it is required when we want some coordinates on line, on the given line. So we assume parametric coordinates. So we can assume parametric coordinates. So we can assume coordinates from this. X is equal to r cos alpha plus x1 and y is equal to r sin alpha plus y1. These are called parametric coordinates. Right? This form is very important. Its importance you will see in coming questions. Let's write a question. If a line is passing through A 1, 2 and makes an angle 45 degree with x-axis and intersects another line 2x plus y minus 7 is equal to 0 at a point Q, find Q and AQ. Question is, a line is passing through A and makes an angle of 45 degree with x-axis. Right, bache? So again I am making a diagram for this particular question. A line is making an angle of 45 degree with x-axis and is passing through point 1, 2. So point is A 1, 2. Now this line is meeting 2x plus y minus 7 is equal to 0 at a point Q. So say this line is this another line which is 2x plus y minus 7 is equal to 0. 2x plus y minus 7 is equal to 0 is intersecting at Q. Then question is find Q and AQ. So when you see intersection, you always think for solving two lines. Now, if you want intersection, if you want to solve, then you need the equation of AQ first, right? So if we recall first or second form, then you want slope and a point. Point is already given, that is A, and direct slope is not given, but its inclination is given. If inclination is given, then tan of that inclination is slope. So if slope is given, if inclination is given, then you have slope and already point is in your hand, then you can find equation of AQ and solve AQ with this line. You can have Q, right? And if once you have Q, then you can find AQ by using distance formula. Then what is the point of parametric form? Why we discuss this form? Maybe this form will give you answer in less time. So let us think with parametric form perspective. So let's say AQ is R. Let AQ is R. So parametric coordinates are x is equal to x1 from x is equal to r cos theta plus x1 and y is equal to r sin theta plus y1. X is equal to r cos 45 degree plus 1 and y is equal to r sin 45 degree plus 2, right? So you will get x is equal to r. Now also this q is lying on 2x plus y minus 7 is equal to 0. So coordinates of q will satisfy this line. So I can write 2 into r cos 45 degree plus 1 plus r sin 45 degree plus 2 minus 7 is equal to 0. So this will be 2r cos 45 means 2 r 1 by root 2 plus 2 plus r into 1 by root 2 plus 2 minus 7 is equal to 0. So 2 by root 2 r by r into 2 by root 2 plus r by root 2, that is 3r by root 2, and 2 plus 2 4 minus 7 minus 3. I will take minus 3 on right hand side, so on right hand side we will have 3, so 3 cancel out, r is equal to root 2. So r is equal to root 2 implies aq is equal to root 2. aq is equal to root 2, and also if you have r, then you have q. So also q is root 2 into cos 45, that is 1 by root 2 plus 1 comma root 2 into 1 by root 2 plus 2. It means q is 2 comma 3. This is all about this question. Okay, so what I have seen in this particular example, I have seen I could do this question by using two methods, but still student is thinking I would use slope point form only, and then after solving the two lines I uh, I would find q and then aq. But if I am giving you another problem, then you will have only one option, and that is parametric equation. Question is, if a 2 comma 0 and b 4 comma 2 and line segment AB is rotated through an angle of 15 degree anti-clockwise through A, then find B dash if AB dash is new line segment, right? So let's start. What I'm saying, question is, if AB is a line segment, if AB is a line segment where A is 2 comma 0 and B is 4 comma 2. Now AB is rotated through an angle 15 degree anti-clockwise, and by doing so this position of B changes and it becomes B dash, right? So I have to find this B dash. Question is this, you remember one question I have discussed in earlier lecture. uh, information was same as in this question, but there we had to find equation of AB dash, right? And you easily solved that one. But in this question, in this particular question, you have to find B dash. So in this question I have to use parametric form to answer. Now in parametric form what we need a point through which a line is passing and inclination which line is having with positive x-axis, right? So, and a distance r at which a new point is situated, right, from given point. So we need three things: x1, y1, theta and r. Okay, so I have x1, y1 as 2, 0. I have theta because inclination of AB I know already. I can find inclination of AB by using slope of AB, right? So slope of AB is 2 minus 0 upon 4 minus 2, that is 1. So theta is 45 degree and this inclination this angle is 15 degree. So you have complete angle, that is 60 degree. So you have theta and also you have r, because if you know AB then r will not change for AB dash also. So and r is what? So theta is 60 degree and r is 2 root 2. Okay, so therefore x is equal to 2 root 2 cos 60 degree plus x1, that is 2, and y is equal to 2 root 2 sine 60 degree plus 0. Okay, so x is equal to 2 root 2 into 1 by 2 plus 2 and y is equal to 2 root 2 into root 3 by 2 plus 0. So no need to write this. So b dash is 2 plus root 2 comma root 6. This is the required answer. Okay. Now note one point. See, if we need to find a point P at a distance r from given point A on the given line, then there may exist 2 points. Okay, one is above A and one is below A, because in question distance r is given. So if distance is taken upward, then distance may also be taken in downward direction also. So if r is given, then we take parametric coordinates. So if r is given and we need to find a point on the same line, then we take parametric coordinates as x is equal to plus minus r cos theta plus x1 and y is equal to plus minus r sine theta plus y1, right? Just say, let us take a question. If endpoints of one diagonal of a square are 1, 2 and 5, 8, then find other two vertices. Okay, what is written in question? Let us draw first. In question, it is given that two endpoints of a diagonal are 1, 2 and 5, 8. So 1, 2 is here, say, and 5, 8 is here, say C. And this is diagonal of a square. And you know very well, diagonals of a square are perpendicular. So other diagonal may be taken as this. So this is BD. And now you have complete square ABCD. You have to find B and D. So for this, I will use parametric equation. And for parametric equation, we need three things. First is point x1, y1. Second, theta. And third, r. Okay. Now collect all these three if you want to use parametric form. Now you know very well D and B are lying on the line segment BD. So you want inclination for BD. If you have slope, then you have inclination. And you know very well the slope of AC. And by using slope of AC, you can get slope for BD. So inclination can be found easily. Now you also know BD and AC are equal. If AC and BD intersect at O, then AO and OD are also equal. And AC you can get by using distance formula, and hence AO. And if you know AO, then you can get distance for D from O. Okay. So for R, you are, then R is also known. Now, what about x1, y1? x1, y1 is a point from which a line is passing, and you want, and you are, on the line BD. So BD is having midpoint O, which is same for AC. So you know x1, y1 as well. So now O is midpoint of AC. So 6 plus 1 by 2, which is 3, comma 8 plus 2 by 2, which is 5. So O is known, means x1, y1 is known. Now slope of AC, which is 8 minus 2 upon 5 minus 1, 3 by 2. So slope of BD is equal to minus 2 by 3. So from here tan theta is minus 2 by 3 implies cos theta is minus 3 by root 13 and sin theta is 2 by root 13. From triangle you can get cos theta and sin theta. Now also EU or yes EU, which is O is 3 comma 5, so 5 minus 2 3 3 square, 5 minus 2 square plus 3 minus 1 square, so root over 13, and which is equal to OD. So if OD is root 13, then OB is also root 13. If I need to find a point at a distance root 13 from O, then there will be 2 points. One is above O and one is below O. So I will use x is equal to plus minus r cos theta plus x1 and y is equal to plus minus r sin theta plus y1 x b comma d r plus minus root 13 cos theta is minus of minus 3 by root 13 plus x1 is 3 comma plus minus root 13 sin theta, that is 2 by root 13 plus y1 is 5. Okay, so b is above, so for b, so d is above, so for d take plus root 13, and b is below, so take minus root 13 for b. So for d, this root 13 cancel out, so plus minus minus, so minus 3 plus 3 comma plus 2 plus 5. Okay, and for b take minus plus, so 3 plus 3 comma minus 2 plus 5. So d is 0 comma 7 and b is 6 comma 3. So these are two vertices, these are two other vertices of the same square, and question has been solved. So students, this was all about today's lecture. Let's meet in next class. Till then, bye bye and take care. Thank you students.